Welcome back. In this video, we are going to see an important concept which is called copy on write mechanism. And we will see why this mechanism is expensive when you load an exe in memory. Or you can say when a loader loads the exe and the dependent libraries in the memory. But before that, we are going to introduce you with a utility which is called dump bin. This dump bin utility is used to see the preferred base address for an exe or the DLL set by the linker. We have discussed about the preferred base addresses for the DLLs and the exes in the previous videos. Please refer those videos. You should use this utility with headers flag or the header switch. Like I have used the header switch for my exe udpserver.exe. This is the output. You can see the highlighted portion here, which indicates the base address of the image where this image or this exe will be loaded into the process virtual address space. Now, let's see how the base address calculation for a DLL to be loaded is done. We know that all DLLs have the same base address 0x10000000, which is by default set by the linker. But can all the DLLs be loaded at the same address? The answer is no. The reason is very obvious, that no two images could be loaded at same location in memory. So, how they are loaded? When all the DLLs have the same base address, then how the loader loads all of them? So, the very first DLL is loaded at the preferred base location, which is the location mentioned at the top. Then, for the second DLL, if the base address is same, which will be same if you have not provided it for the linker. So the linker must have used the same base address. So in this case, loader opens the relocation section of the DLL and calculates the new location based on the instructions in that section. The relocation section of the DLL contains the information like if the base address need to be relocated, then how it should be calculated. This information is contained in the relocation section. Just like the import section of the DLL, the relocation section is also there for the DLL. When the new location is calculated for DLL, and also for the new locations are calculated for the variables used in DLL. In your DLL, you might have written number of variables, you might have used number of functions. So all those functions and variables must have some address. So once the new address is calculated to load your DLL at a new location, at the same time, all the variables inside the DLLs, they also get a new address. Just like here, the address was this hexadecimal address 0x1000005, and then a new location was confirmed, and based on that new location, the new offset location for the variable in your DLL is calculated, and for example it has been set to 0x200000005. So this is how the new locations for the DLL to be loaded in memory and the respective variables used in the DLL are calculated. This relocation causes the performance hit because at the load time, this all action is done. So this section takes some time. This loading or this recalculation takes some time, and this time causes your DLL, your EXEs to be loaded a bit slow. Loader writes to the DLL code page because when you are loading a DLL and you are changing the base location for this DLL to be loaded, then this information must need to be saved somewhere, and this information is saved to the code page by the loader. So this process is called the copy on write mechanism, and this copy on write mechanism is done on the secondary devices like the hard disk. So this writing process and this recalculation of the new address causes the performance hit. So in the next videos, we will see how these problems can be resolved using the rebasing and binding the modules. That's it.